Hello, everybody. Welcome to my session. I'm Mick Hussey from Confluent. I know I'm the last session before lunch, so I'll try and hopefully be interesting. I apologize for the title. It's a very large mouthful, event streaming use cases that transform the business. It turns out the reason it's such a mouthful is that it's actually the name of a book that we publish on our website, 5 event streaming use cases. So you can download that if you feel like it afterwards. So the reason that I'm talking to you today is that what we've seen, and people are talking about it in the other sessions earlier today, is that data is pretty much changing the world. And the most successful companies are all powered by data. The reason all of these companies are up here, you know, Netflix is a kind of poster child for digitalization and for reinventing itself. It's also a poster child for the use of Apache Kafka, which is the open source software that I work with. And these are some other companies. Walmart is the biggest retailer on the planet. Apple is the most successful consumer branded goods and electronics company on the planet. You know, these companies are all heavily driven by data, and they also are all using Apache Kafka to help them deal with that data. And what do you do with the data? Why do you need the data, right? So there's kind of 2 main reasons that companies are dealing with data in terms of digitalization. One is so they can give you real-time personalized customer experiences. You know, this is the sort of thing we're all used to in as customers of these big companies, of these digital native companies, like that. All the data that you receive when you're on Netflix, they're actually doing they're making a big effort to make sure that they suggest the right content to you to keep you engaged with their platform. The other and possibly more interesting part is in the back end, there's a lot of data-driven operations, and this is relevant not just to customer-facing companies, but also to all companies that have logistics, supply chains, that have order-to-cash cycles, you know, traditional enterprises that we're more used to. So the reason that we talk about, you know, event streaming and what is event streaming, and what the first question is, what's an event? And in the context of an enterprise, an event is anything that happens in the business. So it might be the sale of something, a shipment of product, a trade if you're in the finance space or in the energy trading space, a customer doing something in your shop front, an experience on a website, something that happens in a store, right? These all happen in uncontrolled rates because the real world happens to your business. And the idea with event streaming is to actually process them as they arrive and then use these to drive the rich customer experiences and the data-driven operations that we want to enable for our customers. This is a hero slide that one of my colleagues told me to put in, Steve, so I told you I'd give you a shout out. But really, it's all about very large, globally spanning enterprises that we've worked with to help them enable digital transformations. So, for example, Nike, which we all probably have a relationship with as consumers, they have a very interesting supply chain in that they don't really manufacture anything. They do marketing, they do product design, but they outsource pretty much their whole logistics supply chain. And then, of course, that means there's a lot of data being used in the background to make sure that, because they still own your customer experience, and how can they do that when they're not actually touching you at all, right? And they've done an awful lot of work in that space. Walgreens is, well, we probably know it as Boots over here in this part of the world, Boots being the big chain in the UK. They're also present in Sweden, which is where I live. And they basically have the classic siloed enterprise IT supply chain across all of their stores and across all of their delivery of your pharmaceuticals and other sort of things you buy in the pharmacy. and they've gone through a large, especially now with COVID, when people have been very active. They need to have digital experiences, and there's been a very fast digital acceleration there. So what is event streaming? We talk about event streaming all the time, but I think it's certainly from an architecture point of view, it can be hard to explain to people in terms that they're familiar with, right? So when we think of data, we usually think of databases, and I would contend that databases, they contain tables. Normally, that's the kind of the abstraction that we are familiar with. And what a table does is it contains state. So it contains the current state of the world. So if we think of it in terms of, if you put a chess game into a database, then you might have, you'd see where the pieces are right now at the state of the board. Now, the relationship between events and state is the events are actually the history of what happened to the individual pieces on the board. And the outcome of a series of events is the current state. So you can think of a stream of events as being the way you can record the history of how we got to the current state of the world. The state of the chess game, the state of your enterprise, the state of the logistics, where your ships are, where your delivery is, these sort of things. And the purpose of event streaming is to, it's a kind of unification of a number of different technologies. So it's to allow you to publish and subscribe to events asynchronously, which is what we would traditionally have talked about as enterprise messaging. It also, though, on the other hand, allows you to store the events and replay them, which is much more like where we would see, say, data warehouses coming in, or, people have talked about event stores as well. And we're seeing more and more that, once you can store the events, you should also be able to process the events and create net new information, so that rather than processing them once a day in a batch or at the end of the month because you're doing your reconciliation or your bookkeeping, why not deal with them as they arrive? And then you can react to your customer actions in real time, or to things that happen in your business in real time. And you can also infer the state of the world and provide better experiences. And really where this leads to is you're doing integration between different pieces of your business. And if you really want to do this to solve the problems of the business holistically, you need to be able to do it scalable, reliable, fault tolerant. And this is where the use cases come in. What sort of use cases do we see for event streaming? So really, and I guess all the enterprise architects would be very familiar with this idea, you don't do anything in a business unless you can show that it increases revenue, decreases costs, or mitigates risks. So, it helps you be compliant with your regulator if you're a bank or an insurance company. It helps you make sure that you're not exposed to fraud if you're providing services to the public, right? And what we've tried to do is we try to categorize, on these three axes, what sort of places we see use cases that Apache Kafka is being used in the industry today. So, if you read about Kafka, you will find, people talking about it. It originally came from clickstream analysis, right? So it came out of LinkedIn for dealing with the vast number of clicks on their website, so they could actually give everybody a personalized experience without having to do an awful lot of machine learning up front. Then we went into data pipelines and messaging, and they're all very kind of non-use case specific. They're very horizontal use cases. They're infrastructure use cases. So then we see instances of these technical use cases when people are doing customer 360 projects, when they're looking at IoT sensor ingestion, when they're building microservices architectures, they're looking at maybe refreshing their middleware, or joining up their islands of integration. And then there's lots and lots and lots of usages of this technology in the compliance space, in the risk and the fraud space. So as I said, the kind of first use case that we always run into is customer 360, website analytics, this sort of thing, where so for example, I've worked with Swedbank because I'm based in Stockholm, and they have this idea called the operational data lake. And they, just like everybody else, have been on this journey where they went into the big data world and they said, let's store everything forever. And, then discovered that, well, maybe not storing everything forever isn't, maybe we need to do that to meet the regulatory rules. But in order to provide experiences, we just need the data that is in flight right now, plus the history of customer actions. And the operational data lake in the Swedbank case is Apache Kafka. They use it as the kind of the store of the last 7 days or the last month's actions. And the very first project that went live was all about transaction when a customer is on the website doing stuff with their account, what's the next best action? That was a front end customer driven use case. There's also more analytics driven use case around mortgage churn, and they've been adding more and more use cases over time. So this project's been going on for a few years. And really what they're doing is they're combining historical insight, historical customer actions and information about customer profiles together with what the customer is doing right now, and then being able to come up with more personalized offers and content and engaging with the customer in a more real-time and a way that you would expect, right? Rather than always getting the canned. So you can read, I put links in here to where you can read about this. There's a reasonably detailed blog, and then there's more information available out there. Another example of the same sort of thing in the retail space is AO.com, who are based in the UK, and they have the same, they basically, you can imagine what it's been like in this year with the rapid online digital. I think we jumped 10 years in terms of the digitalization of retail this year. And they've had huge growth in customer action, but they also want to, give the customer the right information at the right time. And, through their A/B testing, they've been able to show that the more personalization they can provide, the stickier the customer experience is, and the more they can sell, and the more they can retain their customers. Another use case that's very kind of near and dear to the hearts of all of us who've been in the business a long time is that we kind of reinvent the wheel every 10 years, right? So the problems don't change, the scale changes, and the mix of technologies, and there's always this the enterprise changes over time. We end up with mergers, acquisitions, these sort of things. So like the mainframes, despite when I started in IT in the late 90s, we thought mainframes were dinosaurs and they would be gone, but they haven't been gone. They've stayed, right? What has happened, though, of course, is that they are the systems of record for transactional information, and we need to be able to expose that to the systems of innovation, and that's what we call mainframe offload. And similarly, back in the early 90s, 2000s, we used technologies like JMS, for example, to actually get data between the various silos in our applications. Those, as this becomes bigger and bigger and bigger and more critical, we start running into the limitations of the kind of single broker view of the world. And we need to adopt or enhance that technology. And that's where Apache Kafka has come in as well. So, the CIO of Nordea, who is one of the people that we work with in the Nordics, has talked about it on LinkedIn. So this is a post. I'm not going to go through it now, but it's very interesting to see the CIO of one of the top 50 banks in Europe talking about their use. They normally never talk about technology at this level. And he's quite. They've been very proud of the transformation that they have engendered in Nordea to allow them to actually respond to the market faster and to build better services for their customers over time. And we don't, advocate in any way, shape, or form throwing out the baby with the bathwater. We've invested a lot of money and time and effort in building our current IT infrastructure, and what we need to do is we need to integrate with it. So all of the messaging systems, there are capabilities that allow you to connect between any of the existing messaging systems you're already familiar with and Apache Kafka. And similarly, there's every data-aware system on the planet today is capable of reading data out of Kafka, because it's kind of the de facto integration technology in the modern enterprise. So the way it looks in a very, very high-level IT architecture diagram, this is almost a toy architecture, right? Is we have our current initial, we've integrated our systems of record, say our payment system, with a traditional messaging solution. So we can start off by just using a connector to pump the data to Kafka. So if initially we're using MQ to talk to our applications, we can put Kafka beside it and use connectors to integrate, with the idea that over time we can get rid of, or we can stop using the connectors and have the next version of the transaction generating application talking direct to Kafka if we want. Very often we see that this is introduced into organizations in order to serve an analytics purpose, say landing the data into Elastic. But as soon as you land it into one analytics service, you will discover that there's another team who wants it in a different analytics service, like, hey, Snowflake, right? Or Google BigQuery or whatever. So suddenly the fact that you can have data already available in Kafka and not have to go back to the source system is a huge win, and it makes it much more agile. We also see people building what we would term next generation applications. So two examples being streaming ETL, so the sort of batch flows we would have had when we have a data warehouse as the integration point. We can use Kafka in the same way, but now it becomes a streaming integration point. And another place that usually causes a lot of pain is when we want to deal with security monitoring, so instant and exception monitoring. Usually we have, the Splunks of the world, the ArcSights of the world, but very often it makes sense to put something in front of it to give you some sort of a strategic possibility to use multiple tools and not be too locked in, as we've heard in some of the earlier talks. So streaming ETL, Kafka has an infrastructure. It has basically it's built in a way that Kafka is the data storage layer in the middle. You also have connectors to get data in, so sources. So in this case, you can CDC enable a database, a MySQL database, but it could just as well be an Oracle database or DB2 database, or any of the existing enterprise databases you'd use today. And then you land the data into your, whatever the new system you want to populate, hydrate the data is, say Elastic or Snowflake or whatever. And in between, you often are going to need to transform or join the data so that you don't necessarily have to go and do a project in the source system to generate views that are appropriate for the sync system. So we can do some adaptation of the data along the journey. In the SIM case, the challenge with SIM is we have very, very, very high volumes of data because it's machine data, it's log data, and it's very noisy. And there are a number of incumbent systems like Splunk and ArcSight, Elastic. They all have really focused heavily on their connecting themselves to the data to get the data in. To get sensor data and absorb it, right? But sooner or later they run out of speed because the data volumes are only growing over time. And when you start having to run multiple systems, multiple instances of these things, it becomes quite difficult to manage. And what we see people doing is they use Apache Kafka to front end their existing SIM systems as a buffer in between the two. And that means you don't have to scale the SIEM system as much, perhaps, but it also opens up other opportunities where you can start using different SIEMs for different cases. So you might have, say, your QRadar, which is already built, and you've got your processes for the known issues, but you might also want to have forensic archives of everything in a cheaper storage system like S3, for example. So that's quite a common use case that we see happening. Another use case that's very pervasive is real-time analytics. So stock management in the retail world, pricing of instruments in the finance world. So, for example, Walmart, which is the biggest retailer on the planet, there's always a fight between Walmart and Shell as to who's the biggest company on the world, depends on how you count it. But in any case, they use Kafka to do real-time inventory of stock on hand in stores. And that optimization is a huge benefit to them. And of course, the reason that they're using Kafka is because they have a scale problem. And they feed, their analytic systems out of Kafka.